All right, so here we go. So this is the last core lesson of this unit. After this, it's just another lesson on word problems and applying all these things. So the last lesson is another law. In the previous lesson, we learned about the sine law, and that helped us solve for sides and angles in oblique triangles when we had certain data. And that data, as we see up here, was when we were given a triangle and we knew one of the following formats: angle, angle, side, angle, side angle, or side side angle. And that's very useful. However, sometimes we're not given that data, but we still need to solve for the triangle. So there's another strategy we can use called the cosine law. Now, if we are given any triangle and we know all three sides, there's our snake again from the old similar triangles lesson when we wanted to prove two triangles were similar. Awesome. Or we have two sides with a contained angle. Oh, here we go again. Side, angle, side. Oh, we got our sassy snake. So if we're given a triangle with the sassy snake, either one of those, then that means that we can apply the cosine law. Okay, so we're going to remember the sassy snake. And then if we don't have the sassy snake, then we'll probably have the data to do the sine law, which will allow us to use that one. So search for the cosine law first, because it's probably easier to find. Otherwise, we're probably able to use the sine law. Now, both of these are going to run into the situation where we are finding angles and sides. Always the same thing. We're always searching for sides and angles. That's all we ever have on triangles. So how do we actually apply this? As I said, first of all, we're looking for the sassy snake. If you have the sass, then that means you're looking to find a side. Okay? If you have the snake, that means you have all the sides, which means you're trying to find an angle. So we've set this up, create a little table here to help you remember. If you can remember this table, you'll be pretty good. You don't have to have it memorized, but if you're somebody in the class that has a memory aid or something like that, this might be a good thing to put on the memory aid. Okay, so how do we actually apply it? What does it look like? You'll notice this time it's not a simple ratio like it was for the sine law. In fact, it's a fair amount more complicated, but it's not too bad. First of all, you need to remember that a triangle can be named anything and the variables are arbitrary as long as we are consistently using them within the formula itself. So here's our general formula for the cosine law. Now I'm going to highlight this here. So we have, imagine we're looking for some side length A. Okay, we're trying to find subside length A. So a squared is going to be equal to b squared plus c squared. What is b squared and c squared? Well, b and c are your other two side lengths. So a squared is equal to the sum of the squares of your other two side lengths minus 2 times those side lengths, bc again, times the cos of the angle corresponding to the side you actually want. Holy smokes. Well, if you look at this looks an awful lot like Pythagorean theorem, so that might help you memorize this. A squared is equal to b squared plus c squared minus 2 times bc again times the cos of the angle corresponding to what we're looking for. Okay? So it's always going to be the other two sides for all of your multiples in the beginning, and then it's going to end off with the cos of the angle you're looking, or the cos of the angle for the side you're looking for. Whew. Okay. It sounds more complicated than it is. Do your best to try and memorize it, but for now you could always come back and refer to it, making sure that you remember all the little bits and pieces, right? We're going to give you the equation for a while, but you're not going to be given it forever. So you do need to commit it to memory sooner rather than later. Now, you're not always going to be looking for a side. Sometimes you're going to be looking for an angle. So we have another version of the formula. Pro tip, ladies and gentlemen, it's the same equation, just rearranged. What do you mean by that, Mr. Lane? Well, let me show you. If I have a squared is equal to b squared plus c squared minus 2bc cos of a, okay? You'll see that this piece is being added on. So I'm going to, subtracted. So if I add it to both sides, then what I end up with is 2bc cos A, And then that is being added to a squared, which is equal to b squared plus c squared now on the other side. Now let's get that a squared over to the other side. So we have 2bc cos of a. That's why it's looking funny to me. I don't like that. Okay. And now we're going to bring the a squared to the other side. So that equals b squared plus c squared minus a squared. But we just want to calculate for the angle A. So we're going to divide both sides by 2bc. So we end up with cos of A is equal to b squared plus c squared minus a squared all over 2bc. Bum, 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 bum. And there it is. It's the exact same equation, ladies and gentlemen. So even if you only remember one of them, you can always just rearrange it to find the other one. It's the same thing. Are you looking for a side length or are you looking for an angle? It's the exact same equation, okay? But if you want to memorize it, you can. There's nothing wrong with that. So for a side length, a squared is equal to b squared plus c squared minus 2bc cos a. If you're looking for an angle, cos of a is equal to b squared plus c squared minus a squared divided by 2 times b times c. Okay. Did you get all that? I guess we'll find out. So, luckily it's telling us what to use. Use the cosine law. Got it. To determine the length of side A. So we're trying to find the length of side A. Okay. Round your answer to the nearest unit, so the nearest whole number. Now let's see what we have here. We have a side, an angle, and a side. That sounds like a sassy snake to me. Sassy. Side, angle, side. So, since we have that, and we're searching for a side length, we can apply the original formula. Now they were good enough this time to give us the triangle in the format ABC just to get you used to it. It's not always going to be that way. In fact, the very next question is not going to be like that. So I know that I'm looking for the side length A. So we have A squared is equal to B squared. What is B squared? B squared is 21 squared. Plus C squared, which is 30 squared. Minus 2 times B, which is 21, times C, which is 30, times the cos of the angle of the side I'm trying to look for. In this case, cos of 123. Okay. Now, we can start to narrow this down, but we have to realize that we still have the square here too. So we have to take the square root of both sides, and we end up with equal to the A is the square root of, and now you're going to plug this whole thing in. You know what? I'm not going to write this whole thing out because it's going to take us forever. That is a one calculator setup. Okay. Oops. All right. So that is a one calculator setup, and what you're going to end up with is just A is approximately, A is going to be equal to, let's calculate it like this. A squared is equal to 2027.25. And then that means A is going to be the square root of that, which is about 45 centimeters to the nearest unit. And that's how we do it. We got to just plug in the numbers into this overly large equation that is hopefully not going to mess us up when we're trying to put it into our calculators. Let's try another one. Use the cosine law again. This time we're trying to find angle Z. Okay. Trying to find that guy. Round your answer to the nearest degree again. So this means that we're going to be using the angle version, but we have to make sure we're allowed to. So in order to do the angle one, we have to have the snake SSS. Oh, we do have all three, so that means we can actually apply it. So that means we have, remember we're looking for the angle. So the cos of the angle we're looking for, in this case Z, is going to be equal to the square of one of the other two sides, so let's say 10.2, plus the square of the other side, 6.8 squared, okay, minus, oops, I did the wrong one for 6.8. That is incorrect. That is incorrect. It has to be one of the sides that's not our angle side. So it's got to be plus 9.5 squared minus the side length of my corresponding angle squared, so 6.8 squared. Okay, and that whole thing is going to be over 2 times the first value, which is 10.2, multiplied by the second value, which is 9.5. Putting that all together, what do you end up with? Well, you're going to end up with cos of z, put a little dash in there so we can see what it is going to be equal to 148.05 over 193.8. Now remember, we're trying to find z. So z is going to be equal to the cos inverse of the same thing. There we go. And when all said and done, z is going to be approximately equal to 40 degrees. And that's the whole thing. So we either have Sass for a side length or snake for an actual angle. Okay, let's go try a couple things that are a little bit more challenging. So let's start with this. So again, we're now in the situation where we don't have a picture, so we got to draw our own picture. So let's create a triangle. PQR, triangle PQR. You'll be P, you'll be Q, and you'll be R. It doesn't make a difference which is which. So it tells me that side length P is 4.3. Side length R, oh, that's 4.3 meters. that got confusing. There should be a comma there. Side length R is 2.9. And angle Q is 72 degrees. So we got to look at this. Can we use the cosine law? We have side, angle, side. Oh, that's Sass. So yes, we can use the cosine law. And now we're trying to find the length of side Q. So that means that we have Q squared is equal to the square of one of the other two sides. So let's say 2.9 squared plus the square of the other side, 4.3 squared, minus 2 times the first side, 2.9, times the second side, 4.3, times the cos of the angle of our corresponding side, so cos of 72. Okay? Now, when you do that, we just need to calculate now at this point. So we're going to end up with Q squared is going to be equal to approximately 19.2, which means Q is going to be equal to approximately 4.4 meters. And that's it. Same question, just different numbers now. Now we're going to look for an angle. So now we have, I'll draw it a little bit differently this time. Let's say it's like a triangle like so. Let's say we label this as S, T, and U. Side S is 15 centimeters. That's side S. Side T is 28 centimeters. And side U is 16. That looks like side, side, side to me, which means snake. So now we can use the cosine law, but this time looking for the angle. Which angle are we looking for? We're looking for angle U. Okay? So that means we can write cos of U is equal to our first side length. So in this case, we don't want to use the one that's for our angle that we're looking for. So we're going to say 28 squared plus 15 squared minus, now we use the side length that it's for. So now it's going to be minus 16 squared. And this whole thing is over 2 times 28 times 15. And when we do this, we're going to end up with, let's see, we're looking for this angle here. U is going to be equal to, cos of U is going to be equal to 753 over 840, which means u is equal to the cos inverse of 753 over 840. So u is going to be approximately equal to 26 degrees. And there we go. So now we've done it 2 triangles without actually having the triangle. We had to draw them ourselves. Last little bit, example number 5. So this is asking us, what kind of triangle is triangle STU from question number 4? Is it acute, which means all angles are less than 90? Obtuse, having an angle greater than 90? Or is it a right angle with an angle with exactly 90? Use the cosine law to solve and explain. Now we just calculated for u, which was 26 degrees. So we could calculate for any one of the other 2 sides now. So if I put this, let's say we're calculating for t this time. Okay, so it's still the same idea. So we're going to have the cos of angle t is going to be equal to, so the sides around it, so 15 squared plus 16 squared minus the side across from it, which is 28 squared. Yeah, I think that's right. Yep. And then we're going to divide that by 2 times 15 times 16. And we end up with cos of t is going to be equal to negative 303 over 480. So that means we end up with t is equal to cos inverse of negative 303 and 480. So what do we end up with? We end up with a value of t is approximately equal to 129 degrees. Now let's think about that. Angle t is greater than 90 degrees. So since angle t is greater than 90 degrees, therefore the triangle is obtuse. There we go. So just one little helpful tip that will help you with a lot of questions going forward. The smallest side of the triangle is always across from the smallest angle. The largest side of the triangle is always across from the largest angle. It's just the way it works. Okay? And with that information, you're armed with pretty much everything you need. Now, I can say if it asks us to calculate all 3 angles, the last angle would be really quick. It would just be, well, we know a triangle is 180 degrees. So the only other angle we're missing is angle S. Would be 180 degrees for the whole triangle minus the lengths we know. Well, what lengths do we know? Well, looking at our triangle up here, we know for a fact, or our data, we know for a fact that u is 26 degrees. We also know that this triangle, or this angle t, is 129 degrees. And what you end up with for angle S is 25 degrees. Just in case you're ever asked to answer for all 3 angles, you can now do it. And now we've fully solved that triangle because we have all 3 sides and all 3 angles. And that's where we're going to stop for the day. The next lesson is all about word problems and figuring out how we can apply everything.